Hello, everybody. All right. Well, thank you for spending some time with me this afternoon. The weather's not quite as good as it was yesterday, so maybe it's a little bit easier to be stuck inside a dark room today. But my name's Jay Schmelzer. I'm one of the directors of program management in the developer division at Microsoft, so part of the core engineering team that is responsible for all of our kind of developer products, platforms, programming languages, and services. I spend most of my time in kind of what I think of as the core of the developer division, so Visual Studio, .NET, the programming languages, and recently, over the last few years, also a lot with our Azure Developer Experience group, so the folks that are building tools and services for folks that are targeting Azure. What we're going to do today is spend a little time and talk about some investments we've been making in both tooling and services that really can help you take advantage of the cloud to address some common challenges you have as a development organization or a test organization. Specifically thinking about and looking at how we can use the resources available in the cloud for our development and test environments to solve a lot of common problems that we may have. And we can do this regardless of where your application is going to end up being deployed. Over the last several months, I've got a small team of engineers that we go out and work directly with some of our bigger customers or some of our early adopting customers, and we've helped a number of them move thousands of developers and thousands of testers from working on on-premise physical machines, on-premise virtual machines, to taking advantage of resources in Azure to do their daily development and their daily test work, dramatically reducing the amount of time they spend managing that infrastructure, or more often waiting for that infrastructure to become available to them, while also providing consistency of experiences across all of that, so that there's less, oh, it worked in this environment, but then when I move it to the next environment, there was a configuration problem or something that caused a challenge. So we'll show a little bit of how we do all that, and give you a sense of what that's like. Also, hopefully I'll have some time towards the end. I'll also show you a little bit of how we extend this beyond kind of what we think of as more classic, desktop development or web-based development, to also how we can take advantage of cloud resources for mobile development as well. So I won't make you show your hands or anything, because with these bright lights I can't see anything anyway. But I kind of alluded to at the beginning, a lot of the motivations here are around just helping developers be productive while also providing some consistency across the environment. I spent the first about 12 years of my career as a consultant doing custom application development. And I know, and that was quite a while ago, and I know that nothing was more frustrating for me than having to wait to get access to a new machine or a server, a test environment, something like that, to do my work. That just killed me every time I had to wait for something like that. I've talked to a number of customers. I've heard everything from the lucky ones that have maybe a lead time of a day to get a new virtual machine environment set up. You fill out the paperwork, submit the form, and someone goes and does it. I've heard upwards of 8 months to get just a virtual machine provisioned, let alone physical hardware and those kinds of things. That sucks, right? That's just no fun for anybody. I also know, having been at Microsoft for quite a while, I used to be able to pretty accurately predict how long someone had been at Microsoft by just looking in their office and counting the number of machines they had stacked up under their desk, right? You can imagine working on Visual Studio, working on .NET. We have a lot of different combinations of things that we need to test and reproduce bugs on. Different versions of the operating system, different service pack levels, different versions of Visual Studio, and so forth. And it became a very common practice that anytime you were going to get a new machine, you never let go of the old machine. You just sort of kept it because you never knew when you might need it, right, to reproduce a bug or something like that. So we had these mountains of hardware under people's desks. If you walk around campus today, you don't see that anymore. You typically see maybe 2 machines. Usually a primary developer desktop and then a laptop. In some cases, you just see a laptop because the developers moved all of their daily work into cloud-based resources. So really kind of opening that up, giving us the agility, giving us the flexibility, allowing us to scale to what we need. So we really can also, that's the other challenge we also had, right, was creating a test environment that was representative of what you were going to see in production. That was very costly, and we often didn't have the opportunity or the cost benefit of doing it. So you found things that only happen in production. Allowing us to take advantage of compute resources in the cloud to create those environments when we need them and use them when we need them. Of course, I often hear a lot of concerns as well, right? How do I ensure that the right things are being done and people aren't taking advantage of resources they shouldn't have? How do I maintain security and compliance? Is it going to perform well? If I'm trying to do remote desktop for my development in the cloud, is that actually going to work? Is that viable? And all my resources may not be in the cloud. I may need access to systems, data, source code that is only living on-prem. How do I do that? Is that possible to make that work? And the answer to all of those, of course, is yes. So what we've done is we created a service in Azure that we call Azure DevTest Labs. This is just a kind of convenient service on top of the core compute, so it doesn't cost you anything additional. But what it does is it gives you the ability to address both the needs and the challenges of provisioning data center environments. Through some various studies and things, we've found that upwards of 85, 90% of the resources you have setting aside for test environments, development environments, go unused. You only use about 10% of that capacity that you have on your on-premise environment. That's a whole lot of cost savings you can make. We also know that the vast majority of you in the room and us as developers are very frustrated by the lack of access to the kind of resources and compute and stuff that they need to do their development and test. So we want to fix all of those and address all that by giving you the ability to kind of move from an on-premise set of resources exclusively to moving things into Azure or using a hybrid kind of mix of both, where you can do some things are on-premise and some things are in the cloud. The way I think of it is there's really kind of two sides to this. There's the user of the lab, the person that's actually going in and making use of those resources. And we want to give you the ability to self-service, self-provision what you need. You don't need to go fill out a form to get, spin up a virtual machine. You just go do it. When you're done with it, you turn it off, throw it away, whatever you need. We also want to give a level of control, appropriate control, to the owner of the lab. So you can set up some policies, you can do governance, you can track the cost and the spend and make sure that you're using these resources in an efficient way, in a cost-effective way. So it's sort of balancing the two, giving the user of the lab all the access they need to do what they need when they need without kind of having to go through a big acquisition process, but giving the administrators of the lab just the right levels of control so they can feel good about the use and maintain their own goals from the business side as well. So let's take a quick look at kind of what this looks like from the perspective of a user of the lab. Right? So I'll jump over here. And I've already logged into the Azure portal. In this case, I've got a customized dashboard. And I've got a lab here that we set up for a kind of fictional company. As a user, when I go into the lab, the first thing I'm presented with are a set of resources that are available. You see my virtual machines. So these are machines that I've explicitly created within the lab. And then down below here, we have a pool of virtual machines that have been created and deallocated that are available to anybody in the lab to just grab and use. We use this inside the Visual Studio team all the time for last night's build, right? You can imagine that a common workflow for a developer on the Visual Studio team, come in the morning, grab last night's build, run some tests, do some validation, look into some bugs or something that happened. Nothing sucks worse than spending time installing all that stuff just to get ready to do your job. So what we do is we automate that, and each night after the build is done, we spin up a set of custom machine images that are in the lab and available, and anybody that's part of the lab, when I need to use one, I can just come in, pick one, for example, and just go in and claim it once it finishes refreshing for me. So it's going to claim that virtual machine. It's going to start it. That machine is now mine to do whatever I need to. So in a matter of a couple minutes, I've got my environment up that I can do my tests. I can repro bugs, whatever I need to do. When I'm done, we throw it away. Right? I shut it down, tear it down, and a new one is created in the pool if we want to keep a consistent set available in that pool. So just a great, easy way to manage those things. Now, I've got this other one here. It's called J's primary dev machine. If I drill into that, you see a couple interesting aspects. One, it's a nice size machine, 4-core, 14 gig. That's decent. That's pretty good. Visual Studio runs pretty well in that kind of environment. But what's also kind of neat is we have these two properties down here, auto start and auto shutdown. Because this is my primary machine, I've set it up so that Monday through Friday at 9 o'clock in the morning, this machine will automatically turn on. So assuming I'm like an average developer and I get in around, after 9 o'clock, my machine's there and ready for me, right? I don't have to wait for it to even turn on. What's also nice is it's set every day of the week to automatically shut down at 7 o'clock. So if I forget to turn off my machine, at 7 o'clock, it's going to automatically be shut down for me, right? So no additional resources being spent. Anybody that does virtual machines in the cloud, you've had times where you've left machines on at night, over the weekend, maybe when you went on vacation and you were running out, right? This is just a nice little backstop feature that kind of shuts things down for you. What's also neat about this is it's got a notification system built into it. So we have a simple little, through a webhook, we can specify kind of an alert, a notification, when the machine's about to be shut down. So maybe I'm working late one evening, and it's getting close to 7 o'clock, and I don't want my machine to get turned off. Well, DevTest Labs will notice that the machine is still on. It will send a notification to that link, so an email, a toast, something into a Slack channel or Teams, Microsoft Teams site, whatever, with a link to essentially snooze the shutdown. Right? So I can say, yeah, snooze it for an hour. Give me another hour to work on this, right? And then at 8 o'clock, it'll come in and do the same thing. And if I don't tell it to snooze, it'll shut it down. So giving you some flexibility, giving you some kind of governance and cost control. So that's great for my daily stuff. That's great for things that we use often, like last night's build configuration. But sometimes I just need to go create a new machine or create a new resource. So to do that, I just come in and say, add new virtual machine. And what I'm presented with is a list of bases to start from. Come on, Azure, come back. There we go. And if we start down here at the bottom, we'll see is we have a number of different kinds of things we can start from. We can start from just gallery images. So these are virtual machine images from the Azure gallery that are maintained by Microsoft or our partners. So they're maintained at patch levels, always updated, that kind of stuff. Right? I can start with one of those and then just put whatever I want on it. We can have custom images. So maybe we'll talk a little bit about custom images quite a bit later, but maybe I have some very specific things that I know I need in addition to a base operating system level. And so we'll create custom images as a starting point for that I can go from. We also have even more dynamic mechanisms that we call formulas. And a formula is essentially a set of components, a set of things that we want put together on a machine. So a base image, some additional software configuration, and those kinds of things. That's done dynamically. So when you create an image based on a formula, we will pull from the latest of each of those things and create it for you on the fly. It takes a little longer, as you can imagine, depending on your software. And so that's why people make the trade-off between formulas and custom images a lot. But in this case, let's go, let's pick a custom image. Maybe I'm going to do, let's do a Windows 10 client with VS 2017 on it. All right, I can just come in, give the machine a name, give it a user. One of the nice things is that as part of the lab, for each user, we create an Azure Key Vault instance for you. So you can store secrets, passwords, SSH keys, connection strings, all those kinds of things that you don't want to have to keep typing in. You just store it once in the Key Vault, and it's secure, and now we can just go choose it, right? So, I could pick my VM password, for example. Specify the disk size I want, what size virtual machine, what compute size I want to use. And you'll notice over here that there's only a subset available, and I'll show you why that is in a minute. But I can come in and say, in this case, let's use a 4-core machine. And then I start specifying what additional things I want to be part of this installation. And we call these artifacts. So here's a list of software, essentially, that I might also want to have as part of this custom virtual machine I'm going to create, right? So maybe I'm going to do some stuff with Azure, so I want, Azure PowerShell. What else might I want? Maybe I want, Docker tools installed, and so forth. So I can go through and select these artifacts. And when I'm done, I just say create, and Azure will now go off, and DevTest Labs will go off and provision that virtual machine for me. So in a matter of a few minutes, I'll have a brand new virtual machine with Windows 10, Visual Studio, and then I think I did Azure PowerShell and Docker on it, right? Ready to go. It'll show up in my list. I can connect to it, log in, and I'm off and doing my work, right? So from my, from an experience standpoint, when I connect to one of these, right? Oops. So this is that primary dev box. I've got just a ASP.NET website in here. I can do all my normal kind of developer workflow. Hit F5, do debugging, right? Get all the performance tools. All those things are available to me within here. In this case, I'm using Visual Studio Team Services as my kind of lifecycle tooling and code repository. So it's just talking to Team Services in the cloud to do source code control and a Git repository there. If I needed something on-prem, we have networking solutions to connect Azure to your on-prem environment, whether it's site-to-site VPNs, dedicated express routes, those kinds of things to allow you to do that. So that's the basics of my experience, and that's looking at things that I provisioned as an individual. I can also go in and see other things that I have access to. In this case, I'm both a user and a administrator of this lab, so I see a lot of things. But the thing that's interesting that I want to point out is, in addition to individual machines, the lab can also provision and manage multi-machine environments for you and things that go beyond just sort of infrastructure as a service resources. So at the bottom here, we have this kind of app service, which is essentially using a bunch of PaaS services in Azure. So it's using app services. I think it's got a document DB in here maybe too, if we were to go look at it. Yeah, so it's got document DB or Cosmos DB, an app service and so forth. So we can use that and we can share that across the team. The other one's kind of neat to see is maybe a multi-machine configuration like an SAP test or development environment, right? If you work with that, you know that that's about as small as you can get for a full SAP environment, 4 machines. So, and we don't want to spin that up for every individual developer, so we define it once and manage it through the lab, and anybody in the lab can now use it as a shared sort of development or test environment to deploy to and work within. So you can do database servers, web servers, whatever you need through those kinds of tools. This allows you to do all that, have that kind of flexibility. One of the things that's pretty common is the need to have some data that you want available to you. I don't have any, but we have this notion of what we call data disks. So maybe there's a big data set or a standard test data set that you want to have access to all the time. And so in order to not have to copy that up, we allow you to define a data disk. You can attach that to a virtual machine when it's created, and now you have access to that data set. Is now kind of included in that test environment. When you tear it down, create a new one, you start from that same base. We see this with source code a fair amount as well. If you have a large code repositories, you might do those on data disks. So these are just some of the things that we can do as a user, right, of a lab. And it feels like I don't need to talk to anybody to get new machines, to get things provisioned. I just go spin up what I need, use it. When I'm done, turn it off, throw it away, delete it, whatever I need to do. So let's flip back over here. So I mentioned there's multiple aspects to this, right? We think about it as sort of a worry-free self-service. So you can, as a user, get access to what you need, but as an administrator, you can still control it a bit, right? You can put some governance around it. You can project costs. You can manage costs. You can track spending within the lab. We want to create these things fast, so we want to pre-provision environments that make sense, that are used a lot. That's the claimable virtual machines, claimable environments. Allow you to quickly grab it, use it, and then throw it away. Works great, containerized environments, all those kind of things, all the modern kind of stuff you would do. We also want to make sure that you can share these templates, right? So I'll show you in a second this notion of how we define artifacts and formulas. And so you can share them across teams. You can share them across development organizations. A great example of this, working with a really big customer that's got a global development team. They got developers in Europe, India, the US. Some of them are employees, some of them are not. Some of them are contractors and vendors, consultants. And so by using DevTest Labs, they're able to define an environment, right? Maybe it's a SharePoint environment, maybe it's an IIS and SQL kind of environment. Define it, share it with all these different teams so that they know they're developing and deploying and targeting the right configurations. As those change, they update the central configuration and push it back out, right? So everybody is staying current. You don't have that problem of, well, it worked over here, but we changed configuration and now it doesn't work, and we're spending hours trying to get it from one environment to the next. Since we're all friends here, including people watching us live, I won't say the name, but I actually worked with a big company that the way they managed this in the past was they shipped laptops to their vendors. Over the years, they've lost something like 1,200 laptops because they just probably showed up on eBay somewhere after the contract was over. Think about that's waste. Think about the fact that that laptop probably also had source code on it, right? That's now out anyway. So really giving you cost efficiency, but also a level of control and security that you probably need and want. This is also, just like everything in Azure, it's completely open. It's completely extensible and integratable with everything. I'm going to show you examples today with Visual Studio and Visual Studio Team Services, but this plugs in with any of your existing tools that you may use. You use Jenkins, great. You can work with this, right? Chef, Puppet, whatever you need to use, whatever you're using today for your development process, for your CI and CD will work in this environment, all your command line tools and so forth. So it's very open, and you can use just about anything. So let's take a look at kind of what this looks like from the other perspective. So we saw what it looks like to be a user of the lab. What's it look like if I'm the person responsible for the lab and I need to manage it and set it up? So in that case, I'm going to close out of here. We'll go back into our lab. And this time we'll come down into the configuration and policies area and walk through a couple things. First thing we'll see is the cost trending for our lab. So this is just showing us what resources we've consumed in terms of dollar amounts. So whether that's compute from VMs, whether that's SQL, Azure SQL databases, app services, whatever. Those all roll up. Anything that's defined in the lab all rolls up into this. And then we attempt to project based on that where you're going, right? What your cost trend looks like. You can manage this. So when as the administrator of the lab, you can set kind of budget targets for your lab. You can either do it on a fixed monthly basis, on a monthly basis, like calendar month, or you can do it on a fixed schedule. So maybe you want to do it for a specific project duration or sprint lead duration, those kinds of things. You can set those, specify the budget, and then even set up alerting, right? So, hey, I want to be notified when we start hitting 75% of budget or 100% of budget, so I can, get a head start on knowing what's going on, right, and figuring out what's happening if costs are going different than I expected. Assuming, one of the other things we can do as the owner of the lab, you start looking at seeing, okay, where is that money being spent, right? And so I get a view of by resource where the money's coming, where the money's going out, right? And in this case, I could see that it looks like Jean. I need to talk to him about what we're doing with a build agent there because that's maybe higher than I expected, right? So I can see what it is, who owns it, and how much it's costing me. And if it's out of line, we can go take measures to bring it back in and do as we expected with it. So that's one aspect. That's just sort of tracking kind of from a budget standpoint. When I created a virtual machine, you notice that I only had a subset of the actual compute options available to me, right? I didn't have all of these options for base compute sizes. That's because as an owner of the lab, I restricted some of these and only gave access to certain ones. I mean, as much fun as it may be to do development on a G series in Azure, which are just massive, probably not the best use of resources and cost, right? We can specify kind of quantities of machines in a lab, and we do this from two perspectives. We can specify, a max quantity of machines per user of the lab, or we can specify how many machines in total do we want running concurrent in a lab? So, maybe I have a team of 5 developers working in one lab, and I decide, you know what, we don't want more than 25, or maybe we don't want more than 20 virtual machines, running at any one time in a lab. But each user maybe can have up to 5 at any point in time, because maybe there are some cases where they need to spin up a 5-machine environment or something like that. So you can mix and match those things. The lab will just help you kind of keep those things under control. Auto shutdown, auto start, you saw this. Pretty straightforward. Here's that webhook I was talking about. So if you want to set up the webhook, you can have it kind of notify you when a shutdown's about to happen and give you that option to snooze it. And then auto start. I'll be honest, when we created this and had the idea of auto start, we thought it was going to be the coolest thing. Most people don't use it. Matter of fact, when I go work with somebody, I encourage them, don't use auto start yet. Use auto stop, auto shutdown, absolutely. Put that on everything. But wait to see if you actually need auto start. Turns out we don't use all the environments we think we use every day, right? And turning a virtual machine on is usually only a few minutes. So think about that one before you play with it too much, before you go with it too far. So that's a little bit of sort of that aspect of things. Now let's talk about how we go and share these definitions of stuff. One of the ways we do that is through repositories. So any artifact, any formula it's essentially just a JSON file. It's just a definition that we run. And we store them in source control. And we use Git repositories for that. So in this case, what we've enabled is a public repository, which is one that's owned and managed by the team that delivers DevTest Labs. And it has lots of things. And it's an open source repository that a lot of people contribute to. And then we can set up repositories specific to your company, to your team, with the next level of things that are maybe common. So let's say you have, a company-wide license for, an extension to Visual Studio like, say, ReSharper, right? Well, you can define an artifact that actually will hit your company's license server to make sure that, you're actually licensed correctly. And you can get that as part of installing your virtual machine, right? Maybe you only do that for a team of developers. Well, you can do it at a lower level repository, and you can kind of have some management of these things within your groups. Virtual networks, this is how we do connectivity back to on-prem and other across Azure resources. So you can use virtual networks here to connect back to on-prem resources. The last couple of things we'll look at, the notion of marketplace images. So again, when I created that virtual machine, at the bottom of my list, you saw gallery images. And I only had a few of them available. So we can filter which images from the Azure gallery are available to your lab. And again, nice thing about using these is they're maintained by the person that owns it in the gallery, so they take care of updating it and patching it and so forth. You don't have to do that. Next time you spin a VM with Windows Server 2008 R2SP1, it's going to have the latest patches and fixes, right? On it. You don't have to go do that after the fact. So they're more dynamic in that nature. You can create custom images, put them up there and manage them. The last thing we'll look at is sort of the user permissioning. So in the access control area, one of the things that Azure DevTest Labs does is it introduces a couple specific roles to the lab. A lab user, a lab owner, and a lab contributor. So if you don't want everybody in a lab to have access to all that stuff on the left in Azure, like you want them to be able to use Azure to use virtual machines in a lab, but you don't want them to spin up, Service Fabric clusters outside the lab or SQL databases you can just give them the kind of DevTest Lab user role, and that's all they can do. They can only create things within the lab in the confines of what you specified in the lab. Contributors can add things into the lab setup, so they can add things into repositories and so forth. They can manage a little bit more of the lab setup. And then obviously a lab owner can do everything, including the networking and stuff like that. This is an internal one, so you obviously see a lot more owners than you would expect. You don't normally have that many owners. The other thing that's kind of neat about this that you may have noticed is that there's a mix of corporate identities and non-corporate identities. So I mentioned the customer that has consultants or vendors that work with them. Here would be an example where someone like Elizabeth is using her corporate credentials, right? I granted them through our Azure, our AAD kind of federation with our identity. But the one below is a Hotmail account, just using a Microsoft account. So that may be a consultant that we brought into the project for a while. So we can grant them access to the lab for that period of time. When their contract is over or the project's over, we can remove them from the lab and they no longer have access to anything. So giving us a little bit of a convenience for working in those kinds of situations. Make sense? And then there's tagging and all that kind of fun stuff that we use for other things like, helping with cost reporting or billing and all that kind of fun stuff that you may need to do. So all of the normal Azure kinds of things, flexibility-wise, are also there as part of this. All right. You guys are really, really quiet. It's kind of freaking me out. So that's a little bit of the basics. Now, I mentioned that custom images are something that happens, and custom images are actually something that in a lot of big lab deployments, we tend to find pretty common. And there's a lot of reasons for it. You may have some software or configurations that are kind of complex. You may want to have specific versions of things on the machine. You don't want to pull them dynamically when they're created. Most often, it's even the cost aspect of stuff. So with a formula, you turn on the virtual machine, and from that point on, through all the setup, you're getting charged for the virtual machine running, right? You may not want to do that if you have common configurations that take a while. Maybe you're installing some database software or development tools, and they take time to get installed. You don't want to pay that for every single person starting up a machine. So you would use a custom image to pay that cost once, and now it's just spin up time, right? No more setup and configuration. The compliance aspect is another one where there's strict security policies around how machines are joined to domains or naming conventions and that kind of stuff. Custom images give you a better capability to do that and know that that's going to be, follow your compliance and stick to the rules that you have there. But while that's great, it also adds complexity, right? You could do all this by just creating VHDs and uploading them to the lab and letting them spin up from there. But in today's era, you kind of want to do something that's a little bit more manageable, a little bit more flexible in the sense that using things like configuration as code, so we can go and define this stuff in code, version it, manage it that way, right? Track changes, track things that are different between image A and image B more easily. Have the ability to spin these up and generate them automatically. I've a great customer that we're working with, and this actually happens inside Microsoft a lot too. You can imagine that for a big software company, we have many versions of an operating system we support at different service pack and patch levels, at different localized, language kind of capabilities. So we have this like multi-dimensional matrix that gets huge. Manually creating a base image for each of those would be a nightmare, and then keeping it current. With something like a factory pattern, we can kind of automate that process, scale it out more easily, make it happen, as often as we need it to, either on a daily basis or only when changes occur, and then distribute it out from that central location to hundreds or thousands of labs that we may have across the company. And we do it all with just common tools like Azure PowerShell or any kind of scripting that you would want to do. So let's take a look visually at what that would be. So imagine, we're in an environment where either we have a bunch of teams that are working at different things, or we have teams that are distributed geographically right around the world. And rather than have everybody come back to the same Azure data center, we want to give them the ability to have their dev and test resources in a data center that's more local to them. So maybe have a team in India, one in Europe, and one somewhere in the US. So in this case, what we will do is we will create those images, those custom images, and then distribute them to these individual labs on a kind of automated basis. So now they're available local, and they can quickly be spun up and instanced for each person in the lab. Lots of ways to do this. The example I'm going to show you today takes advantage of Visual Studio Team Services as kind of the orchestration engine for this. So we'll use Visual Studio Team Services and their release capabilities to orchestrate the process. But essentially, all we're going to do is execute 4 stages. We're going to go and create virtual machines. We're going to have those custom images saved. We're going to distribute them to the individual labs. And then we'll do a cleanup process, right? We'll remove maybe expired or old images whatever we want to do that's specific to our case. So we'll basically take those 4 steps and let team services kind of orchestrate that for us. So drilling into the solution a little bit, here's kind of the steps we're going to take. We're going to create what we'll call a golden image, right? We'll define the base that we want for this image to be. We'll check that into version control, and then we'll have Visual Studio Team Services kind of kick off the actual creation of those images and then do the distribution for us. So if we could kind of switch back over here, I go into a little bit of a demo flow here. So if I wanted to go and define a new custom image, well, one of the easy ways to do it is to actually come in here to the portal and say, hey, I want to create a new image. Grab the base, so maybe, this Visual Studio. In this case, because we're creating a definition that's going to be used for custom images, the name, user, and password actually isn't important. We're not going to actually use it. I just need to use it to get through this part of the flow. Even the base compute size isn't important because that's something that can be replaced when we actually spin up the instances of the images. What is important are the artifacts. So, do I want Azure PowerShell, maybe something fun like, what else kind of fun stuff do we have in here? Maybe Notepad++, something I want. And notice these are all coming from the public repository, so these are available to anybody. So I'll say OK, and I've defined what I want. The last thing I'll do is come down here and click this option to view the Azure Resource Manager template. So this is the definition of that image that Azure uses. Now I can take this, copy it, right, and check it into version control, and it's now the definition of a base image that I want to use. So if I switch over to this instance of Visual Studio Team Services, what you'll see is I've got, my project here. I've got this folder called Golden Images, and inside of it, I have a set of kind of image configurations. Now, in this case, this is just a pattern that we chose to use. It's not a requirement, and I'll show you where all these scripts are so you can take them and adjust them to how you want them. But essentially what we've done is said, okay, let's create an area for golden image definitions. For each base operating system, let's create a folder. So in this case, we have 2008 R2. We have one image definition that's based on that, so this JSON file here. If I go in and look at it, you'll see kind of everything you expect, the name of stuff, what lab information we need, versions of the machine types, the base images, and then towards the bottom, also in here, we'd see artifacts if we had some. I don't think that one has any. If I go over here, in this case, we have 2 different types of images based on Windows 2012 R2, right? So each JSON file is a specific golden image, custom image that we want to create, and we just gave ourselves a little folder structure to organize it. So again, same kind of basic stuff. Most of this we picked up from the ARM template was generated in the Create tab there, right? And then, when our process runs, it'll go through and it'll look through, find all the JSON files in these folders, create the images, and so forth. So the other piece of this is the distribution. I mentioned that you don't have to push every custom image to every lab. You may not want to do that, right? You may not need to do that. So we have this labs.json file that allows us to control the distribution. And so this is a little example, but for each lab, you'd create an instance of this. You'd specify, what's the name of the lab, and then what images do you want moved. And because we structured it the way we did, our image paths can either be the folder, in which case it's going to grab every custom image under that folder, or a specific JSON file, right? Either way you wanted to do it. And then we'll just make sure that those things are distributed to the labs when they're created. So the actual way that this works is we have a kind of release pipeline that's set up that orchestrates this operation and calls all these scripts for us. So if I go in here and we look at kind of one of these specifically, you'll see that we basically have stages, right? Each environment is a task. So starting the agent, creating the virtual machines, you're saving those images once they're created, distributing them to the labs, cleaning up whatever we need to clean up, stopping the build agent, right? So each of these is just running, one or more PowerShell scripts to actually do the operations. Now, the reason it's kind of nice to do it inside something like VSTS is it gives us the option to continue even if everything didn't work, right? So maybe one image failed, and I think that's probably what happened in some of these here, right? If we were to go in and see, well, actually, some of these are set to be manually viewed, but in some cases, hey, actually, yeah, that's right. The way this is set up is if it fails, it's going to manually wait for you to look at it and say, oh, okay, one of 3 images didn't create. Big deal, let them go, right? Let the other ones continue. Go ahead and distribute the ones that worked. Don't block everything just because one thing failed, right? So it gives us some more flexibility, surfaces those things up here quite nicely for us. So just an example of how we can kind of coordinate and orchestrate across all of this. I mentioned all of this stuff is available. So if you go to this GitHub repository, you'll see that all the scripts that we use, all that stuff, examples that I have in my VSTS instance are all there. So you can grab them, pull them out, and do what you want to with it. I have a link to that at the last slide here in a second as well. So here's an example of what the entire process would look like as a single script, right? Without a bunch of good error handling on it. But essentially, if I wanted to go try to run the whole process just from my local development machine, I would just run this script, and it would go do all the work that VSTS was doing for me, right? Or I could run it from anywhere, right? Again, you don't have to use VSTS. It's just the orchestration tool we chose to use. I talked to this a little bit when we saw it, but essentially each one of these scripts is a separate task inside the orchestration tool. VSTS does a nice job of showing the errors up to the top and making it available to us, but also allows us to go and store these tasks as code and scripts so we can version them, we can manage them the way we do everything else. It also gives us the opportunity to continue if one aspect of this failed, but we don't want to stop, we don't want to fail the whole image build. So that's just some examples of how these things work to make it more efficient. With that, I'm going to transition. So we've talked about kind of DevTest Labs and how we can use DevTest Labs to manage resources, give developers access to the environments they need, create consistent environments, environment definitions, share them, automate them, and so forth. But one of the things that's kind of challenging today, if you build mobile applications, is testing those applications on the various types of devices that are out there. If you want to have a 5-star app, you can use emulators for a lot of things. It's great. They're really good for what they do, but at the end of the day, you're not going to know if it's not really tested on the physical device. So let's take a look at a cloud-based solution for that. So here I'm looking at Xamarin Test Cloud, the predecessor to Visual Studio Mobile Center, which is kind of the next kind of iteration of these kind of tools. And what Xamarin Test Cloud allows me to do is run tests on physical devices. So, I specify an application type, and now I have access to over 2,000 physical devices in the cloud, right? I don't have to manage them. I don't have to worry about them. These things have all the possible combinations you could imagine. We put them behind, a firewall so they don't get automatic updates and things like that. We can keep them locked to specific versions of iOS or Android and so forth. We have all different types of form factors. They're on these cool little rigs. So if your test is, wants to rotate, see what happens when you rotate the device, we will physically rotate the device for you. All that kind of cool stuff. So when I run, specify one of these tests, I can just go schedule it and run it. So here's an example of a test run. Okay, this ran, you can see some high-level stuff. Looks like I had 2 main tests in here. One of them failed. It failed on 8 out of 68 physical devices. I can drill in and start looking at, I see a bunch of other stuff, right? Like, hey, were there specific form factors or operating system versions? I say, yeah, they all happened on the phone. This was an all Apple device thing. When I get into device failures, oh, look, looks like they all failed on, well, almost all of them. Most of them failed on a 4S. Okay. That's interesting, but I want to know more, right? Well, let's look at what happened in this test. So this test had 3 steps. Essentially launch the app to get the login page, do the login, which then should show the main page, and then This is for like a bike sharing application. Then book a new ride, right? So there's 3 primary steps that we define in our test. Here's what all the devices look like on step 1. Everything's green, everybody passed. Step 2, we had some failures. All right, here's what the device looked like at the point of failure for those devices, right? And if I scroll, I think you'll even see, so that's all of them. But there's those 7. Then we go one more step. Those first 7, the 7 that failed in the first test, they fall out, right? Because they couldn't go any farther, so there's no results from the next step of the test. And then we had a new failure, right, on one of the other devices in that step. So that's cool. We can kind of see what happened, and if I get real creative and click fast, it's almost like I'm watching a replay, right, of the screen of the device. All right, you guys didn't think that was funny. Cool. So let's look at this first one. We can drill in. Here's the screenshot of the device. I can get access to the logs from the device. I can see what's going on in the test. And I realize it's small, but in this case, what it's saying is it's waiting for an element it's waiting for the sign-in button. The test timed out trying to find the sign-in button. Let's go back and look. There's no sign-in button. That doesn't seem quite right. Well, let's go down to some of the other ones, right? And realize that in these other cases, what was happening, the sign-in button was there, right? But then when the script went to type into the text box and the keyboard popped up, it obscured the sign-in button. So we didn't find a crash, per se, but we found a user experience bug, right? So this thing, of course, can find crashes and stuff like that, but it's kind of cool that it actually finds these kinds of things as well. And to be honest with you, totally legit. We were going to go through and cook up like a fake crash, like, one of those iOS 10 throw exception kind of things. And then we found this one just running this test. We're like, oh, this is pretty slick, right? So that's that example. Another example, when we saw we had one more test that failed over here on this device, right? If we look at what happened, this device was set up with, didn't have location services turned on, right? So, and the app required it. So it's going to fail the next steps of the test, right? So again, giving us all kinds of devices configured in all kinds of different ways and allowing us to have direct access to this stuff. Pretty cool? Anybody using this stuff today? Anybody going to go play with it tomorrow? Yeah. It's slick. And of course then, we can hook this up with the next level of stuff. We can hook it up with things like Hockey App and so forth so we can do distributions and we can get even more data back from our users. But this just giving you the ability to go and run your app on physical devices in the cloud across a wide matrix of stuff that you don't have to manage, right? You don't have to worry about it. We control it. We manage it all for you. We get the devices and so forth. And actually, if I look at this as a whole, you'll see that, in a lot of cases, this kind of demo was set up to where, hey, this is our CI testing build, right? So rather than running, 68 devices every time we do a build, we just pick a smaller set and a smaller set of tests, right? And like, okay, every build will do this small group, and then maybe we have a larger test for, more of a later integration suite or something like that, because they do take time to run, and you don't necessarily want to spend that on everything. So just a quick view of an aspect of how we can extend this kind of resources in the cloud to also include the mobile experience as well and have those device form factors in there. So hopefully what you got exposed to, and again, I don't expect you to walk out of here and be able to go implement Image Factory tomorrow, even though the scripts are there. But it's really more just kind of getting you thinking about what's possible and where the cloud may be able to help you and your organization be more efficient, right? Through the ability to quickly provision environments, no more filling out paper forms, or email forms or whatever level of sophistication you're at, waiting for it to work its through approval and acquisition and provisioning and so forth. Just spin it up when you need it. Confidence in the ability to maintain and manage the costs and have the oversight of what's going on within the lab by either restricting access to things or setting these budgets and resource limits and stuff like that so that you can get notified when things are trending in a direction you didn't want. The ability to create consistent templates, whether it's the very dynamic things like formulas and artifacts that are pulling the latest versions of stuff, can be shared as sort of code artifacts because they're just JSON files across the team, to actually creating custom images that make those standard configurations available instantly to people, reduce the costs because we build them in a central location and then distribute them out to the places that they need to go and be used. And of course, the ability to kind of open this up and use it with whatever tools you have today. Right? You saw in my lab example there, I've got Windows machines, I've got Linux machines, I've got Visual Studio on some machines, I've got other development tools on others. Right? We can use VSTS, TFS to help as part of this and integrate in. So one of the great things that we've added to those products is as part of the build pipeline, there's tasks to deploy into a DevTest Lab instance, right? So you can build your app, deploy it right into an environment that's ready for testing. As part of that, you can run tests through there, the release pipeline hooks on it, so forth. But you can also hook it up with Jenkins or Chef or Puppet or whatever you're using, right, to manage those kinds of things for you. It's all just kind of configuration and treating it all as code artifacts. With that, a few things to look at. One, the portal. By the way, because DevTest Labs does not cost anything, it's just part of Azure, you're just going to pay for what you use inside the lab. You can go play around with it, explore it. If you don't like it, delete it. No harm, no foul. If you're an MSDN customer and you haven't used your Azure benefit, you can certainly use your Azure credits as part of this, right, to explore it and understand it. Some links to the lab. The bottom one is the one you really want if you want to play around with this. That's the link to the GitHub repository, shortened as best I could. So aka.ms/DTL image factory. That has those example scripts that we use. And these are scripts that we're using with customers in production to manage labs that support thousands of developers and thousands of testers globally distributed. So it's a process that works. And it's also, again, in those cases, those are all applications that are deployed on-prem in the end of the day. So they're doing their development, they're doing a lot of their testing in the cloud, but they're deploying the application back onto on-prem data centers later, just getting the benefit of having cloud-based resources for dev and test rather than having to procure it and manage it yourself. So with that, we got a few minutes. If there's some questions, happy to take those. Wow, I can actually sort of see. Yeah, go ahead. Is this available on Azure Stack? It is not part of Azure Stack today, but it's just built on core Azure stuff, so we can, in the future, we could do that. Yeah. So if I need to ask for money to pay for this, how do I know what I need to ask for? Well, so all you're paying for is core compute, right? So it's the same as you just look up the Azure costs for the types of VMs you want to use, and that's what your cost calculator is going to be. I realize that's not the best answer in the world, but that's the high end, right? And then, through the auto shut off and those kinds of things, you can come down below that. A lot of times what we will do is we'll do some back of the envelope spreadsheet calculations up front, and then we'll run a pilot lab for, days, weeks, months, depending on what we're trying to accomplish, and just watch what happened, right? And we'll do that inside of a smaller subscription or something like that. So yeah, costing is still a bit of a challenge, but yeah. Yeah, I'm sorry. You're paying for the core Azure, for the Azure resources you're consuming is the better way to say that, right? So that could be compute, that could be storage, PaaS services, whatever you're using in Azure, you're paying that cost, nothing on top of it. Yeah. Yeah. So I'll go back over here and show you real quick. The question was, inside of I assume you're talking about the mobile stuff, right? Yeah. So in this case, when I've got these set up, in this case, I've got iOS, right? So you see that I've got iPads, phones, I've even got iPod Touches in here. I select which of these types of things I want to run my tests against, and that's it, right? Now, you're limited by what we have in the cloud. So you're beholden on us to make sure we have the latest devices in there or the types that you want. But then you can take the subset that you want to run your tests on and target. Ah, great question. So the test cloud doesn't care how you built the app. So test cloud can test applications that were built with Xamarin technology. It can build applications that were built with Swift or Java, right, directly against iOS or Android, React applications, anything. Matter of fact, some big customers of Test Cloud are using it to test their air quotes natively developed for each iOS and Android kind of application. In fact, I think we've talked about folks like Slack and Pinterest use this, right? Because it gives them access to the devices, and we don't. This infrastructure doesn't care how you wrote the app, so you can use any technology you want to with it. Yeah. Yeah. So auto shutdown versus auto hibernate. Man, I would love to have that. It's kind of a limitation of Azure right now. Azure doesn't really understand the notion of hibernate a VM. Plus, it won't give you quite what you want from a cost savings perspective. So what we're getting to is, we hope to be able to do in the future is have kind of memory state capture as part of that. So when you restart, you actually restart like you were hibernated, right? But we don't have it today. Today it's a shutdown. Yeah.
The virtual networks for the on-premises resources.
Yep.
How complicated or opening, closing individual ports, or is it just a tunnel that you can open up?
So the basically, so yeah, the question is what kind of options do I have for connectivity between Azure back to my on-prem? It runs the gamut. It can be sort of virtual networking-based solutions, right, where you're establishing a site-to-site virtual network. It goes all the way up to dedicated, we call them express route connections between your data center and ours. So between your network and Azure, right? A dedicated pipe, only you travel on it, and so forth. I've seen both. I'd say the most common one right now is folks that use ExpressRoute because they need access to on-prem resources, or they want the Azure VMs to be domain joined, that kind of thing, where you want a higher bandwidth kind of pipe. But it all depends on your scenario. But we can follow up on that offline if you want and chat about it. To just get a pilot going, we don't usually go that far. We'll do something much more straightforward. Pick a scenario that doesn't have on-prem connectivity needs or has smaller needs for on-prem connectivity than hitting a service that's on-prem or something like that. Yeah. Yeah. Is what? Oh, absolutely. So in DevTest Labs, I can create anything I need, anything I want, right? We use it for ASP.NET Core development. We use it for ASP.NET development. We use it for WinForms development, right? We use it for Visual Studio development, right? Which is sort of a combination of everything. And then customers do all those kinds of things. So, cool. I think we're probably about out of time. I appreciate you spending the hour with me. I'll stick around a little bit if there's other questions, and enjoy the rest of the conference. Thanks.